Okay. Draw a graph first. For object, the minimum speed that is required for this object to go a full loop. To find the minimum speed, we need to find the minimum speed of the object when it's on the top and when it's at the bottom. So when it's at the top, there will be a centrifugal force and a normal force and gravity. This normal force, that is a centrifugal force. The centrifugal force will equal to the normal force plus the gravity, that is gravity, m times g. And because it's a minimum speed, so when the normal force equals 0, when the centrifugal force is exactly equal to the gravity, that is when the speed reaches the minimum, and that's 0. For the centrifugal force equal to m times speed over r, speed squared over r to mg. Okay, we need to find the speed, and cancel m, and let's call it the top, because it's at the top. At the top, the minimum speed required is g r, right, and square root. So now we know the speed required for the top, and we can find at the bottom now. At the bottom, we use the kinetic energy formula or equation. So the potential energy of the top, potential energy plus is kinetic energy, that's the top, equal to the potential energy of the bottom plus the potential energy, the kinetic energy of the bottom. Since it's at the lowest point of the graph, we consider the bottom's potential energy as 0. As 0, then we replace with so the length, the height is 2r, and the potential energy equal to the gravity, the force, and the work done, the displacement is 2r, and that is mg. So mg times 2r plus, we all know the kinetic energy equation is 1 over 2 times m times v squared, and v squared, that is v top squared, equal to the kinetic energy of the bottom. The kinetic energy of the bottom will be 1 over 2 times the mass times the speed of the bottom. So this equation should be true, and we cancel m 2gr plus 1 over 2 v top 2 equal to 1 over 2 v bottom. We've already found that the v top is square root gr, and the square of the square root gr will be just gr. So 2gr plus gr equal to 1 over 2 V bottom with bottom minimum, and plus 1 GR V bottom will equal to the 1 plus 4 5 GR. Okay, or square root. The V top is square root GR, and the V bottom is 5 square root 5 GR. And we can use the same method again to find the minimum speed required for the object when it's halfway down. So it will be the potential energy of the medium plus its kinetic energy, and the bottom is the rule of conservation of energy. The energy, the setting is very slippery, and there is almost no friction force, friction 0. Coefficient of friction is equal to 0, and the potential energy will be the G times the height. The height is r, half of 2r, because the radius is r. The radius, so this m times g times r. This is the potential energy when the object is halfway down, plus its kinetic energy. Bottom is 5 GR. That is the speed. This is 0 because it's the lowest point in compare with halfway. Its potential energy will be 0, and its kinetic energy to mv squared. And we just plug in the V bottom with square root 5 GR, and we can find the minimum speed required for the object when it's halfway down. And maybe I can skip to GR. Right. And finally, this 2. The minimum speed for the object when it's halfway down, in order to go a full loop, will be square root 3 GR.